So today we're going to look at transforming graphs of functions, and that probably should say functions with an S. But what we're talking about is actually a little different because when we usually talk about transformations, we're thinking about reflections, rotations, translations, and dilations, and we're thinking about it in a geometric kind of context, like reflecting a triangle or rotating a triangle. This is a little different because we're talking about taking a graph of a function and reflecting it or dilating it or shifting it up or down or left or right, which is a translation. So it's really the same type of thing. We're still talking about the same types of transformations, reflections and translations, etc., but it's a different context. We're talking about looking at equations and looking at graphs and talking about how the graph changes when we do different things to the equations, and which of those things mean that we're going to be shifting it up, or which of those things in the equation mean we're going to shift it to the left, or to make it taller, or skinnier, or wider, or anything like that. So first off, we're looking at quadratic transformations, or quadratic functions, excuse me. And we haven't really studied quadratic functions at this point, and so I wanted to use them mainly to point out that you really don't even have to know anything about a particular type of function in order to see what various transformations can do to it. So what you're going to do is you are going to first go to open another screen so that you can pull up Desmos. Desmos is it's a website that has a lot of different things, but one of the things it has is a graphing calculator that is very convenient. And you're going to hit launch calculator like I just did there, and then you can type your function in right here. Notice, and I don't know if you can see this on mine, but notice that right down here where it says show keypad, you have this option to bring up all of these things, including squared, square root, pi symbol, etc. So what we're going to do is we're going to graph a quadratic function, and first we're going to graph the most basic example of a quadratic function. A quadratic function is any function where your biggest exponent of x is 2, x squared, x to the second power. So your most basic example would just be y equals x squared. Notice I click this a to the second to make x squared. So that being the most basic, simplest example you could ever have of a quadratic function, we call it the parent function for all quadratics. So in other words, any other quadratic is going to be a little bit more complicated version of this. The x might have something added or subtracted from it, or it might be multiplied by something or divided by something, but it's basically a dressing up of this basic quadratic function. So looking at your chart, you need to go ahead and graph that for yourself, doing the table of values, completing the table of values, and then graph it on the coordinate plane at the right. You might want to pause to do that. I'm not going to wait for you. Now, what we're going to do next is I'm going to put different things in here to see how that changes my graph. For instance, the first thing on your chart says multiplying x squared by a number. We're talking about out front here, putting something else in here, and I'm going to put a letter A right here. Now notice, and you're going to be doing this on the back of the sheet, so notice it says add slider. Here's what this does. If I click on the A, now I have a slider that I can move to give different values to A, to try out different values. Right now it's 1. This is y equals 1x squared. Notice some of the points that you graphed. There we go, right there. That should be one of the points you got when you graphed on yours. This should be one of the points you got when you graphed yours. Over here. This is one of the points. And this is one of the points. And it's good to have specific points in mind so that we can see exactly what happens to those points when we move it. And that's at 0, 0. Okay, so I'm going to move A equals 1. I'm going to make it A equals 2. Now you notice as I was moving from 1 to 2, the graph was getting narrower. But we don't really think of it in terms of that narrow and wide. Sometimes we can be asked, does that make it narrower or wider? But what's really happening here is a vertical stretch. What that means is, for instance, originally the point 1, 1 was on that original graph. Now, for x is 1, y is 2. It has been stretched upward so that it's like the height above the x-axis is twice as tall as it was before. If I change this to 3, the height above the x-axis is now 3 times what it was. For x is 1, we have to go up to 1, 2, 3. So this is a vertical stretch. If I use a number smaller than 1 but not negative, in other words a positive number smaller than 1, it makes it wider, like 0.5. Now instead of stretching it twice as tall or 3 times as tall, it's half as tall. Instead of 1, 1, which would be right here, we're at 1, 1/2, 1 and then 0.5 for y. So it's now half as tall as it was, which makes it wider. So that's a vertical compression. So when I multiply by a number that's bigger than 1, it stretches. Smaller than 1, but still positive, it compresses. And a vertical stretch makes it narrower. A vertical compression makes it wider. So that's the first thing we want to talk about on your chart. Now, notice I said a positive number greater than 1 or less than 1. Using a negative number does a completely different thing. What's that doing? That would be reflecting it across the x-axis. If we compare, how about y equals 3x squared to, I think I'm going to go ahead and input separately, y equals negative 3x squared. They're reflections of one another. Okay, so putting a negative out in front does that, reflects it across the x-axis. How about adding and subtracting? I think I'll go ahead and take my a and put it back to 1, which is sort of like the default. Here's my parent function again. And I'm going to add a letter. Let me add it inside. And notice this is not the next thing on your chart. This is the bottom of the chart. I'm adding it inside the squaring. In other words, whatever's happening to x, which is it's being squared, I want that to also happen to my, I'm going to call it plus b. But to show that x and plus b are both being squared, I need to have parentheses. And it needs to be around just the x plus b. So I added it inside the squared function by putting plus b inside parentheses with x. Now that's being done before we square it. So I'm going to add the slider for b. And right now right now it's at 1, so that's plus 1. And notice that it's moved this direction 1. That kind of may be different from what you would expect. There's plus 2, plus 3, plus 4, and plus a negative is just like minus. So plus negative 1, here's plus negative 1, which is x minus 1, x minus 2, x minus 3.2, x minus 4, 4.1. So think about what happens in terms of what makes it move to the left and what makes it move to the right. And we put that in terms of addition and subtraction. Okay, so that's my adding or subtracting a number inside of the function. In other words, inside of the squaring. I'm adding or subtracting a number before I square. What if I add or subtract a number after squaring? In other words, I do whatever squaring I'm going to do, and then I add c. Notice I moved b back to 0 so that I'm not adding or subtracting anything inside here. Oh, and by the way, make sure you think about, well, I'll come back to this, but make sure you think about the words horizontal and vertical too. So here we go. This one is plus 1 for C. So this is whatever times x plus or minus whatever squared, and then plus 1 at the back end. Here's plus 2, plus 3, plus 4. So this is written here at the back of the equation. So outside of the squaring, so this plus 4 is not being squared. And here would be minus 1, minus 2, minus 3. So think about what that does in terms of up and down, in terms of whether that's vertical or horizontal. It's a shift because it just shifts the whole thing. It doesn't get wider or narrower. Okay, so that's a vertical or a horizontal shift is how we usually phrase that, which would also be a translation. And that's what you want to write, is figure out which one of those is appropriate to write in the blanks at the bottom. Now you're going to do this again, but this time you're going to do, and this is on the back of the page, the absolute value function. So I would say, let's go ahead and put our parent function. Remember, a parent function means the most absolutely, notice right down here you have absolute value. The most basic absolute value function there could be, and that would be y equals absolute value of x. There it is. That is the parent of all absolute value functions. Every other absolute value function is basically a dressed up version of that one. So it's up to us to figure out what happens when we dress it up. So let's go ahead and do this. First, I'm doing exactly the same thing. Notice it's a different color. And what I'm going to do is I'm going to add my sliders here. That would be multiplying out front. And or here, adding or subtracting inside the function. And or here. Okay, you may want to add them one at a time, and you can close these out. You can put them to 0. We don't want to put a to 0 because if we do 0 times that, we have no more x, no more absolute value. But we could put these to 0 so they don't impact anything, or we could close them out. So that one at a time you want to examine what impact this has on your graph. So go ahead and walk through all of the parts of the chart down at the bottom, experimenting with adding and subtracting numbers inside the absolute value, outside the absolute value, numbers out front, and also negatives out in front of those numbers out front. And we will finish talking about this tomorrow.